Live. Hey everyone, so we are going to continue with the Chapter 5 lecture. As I always like to do, I like to start with the discussion around why this is important. The same reason why if statements and conditional statements were important is the same that is true for what are called loops. We're going to get into loops. And conditional statements, if statements, switches, you're going to find them in every language. You're going to find them in old languages, new languages. They're just part of coding. It's part of development, and so you can't escape them. So you have to be very comfortable with them. In fact, it's probably one of the most important things that you can learn in school. Just these foundational things. Okay, all these advanced concepts. You know, that's great, but if you don't know the foundational things, you're in trouble. And so these loops, again, you know, so many employers just give me people with the foundational skills. And this is a foundational skill. It's going to be in every app you've ever used. And so while if statements, I say make your programs smart, loops make your programs powerful. And what I mean by that is that you can write a little bit of code that executes repetitively, you know, hundreds or thousands of times. Okay, real world example, we've all used Amazon. You go to Amazon, you search for your favorite product. I always use the example of a basketball. Okay, you search for an Amazon, you search for a basketball. And you can probably imagine pages of results coming back from Amazon. And so what a loop would do is it'd say, okay, we're going to query a database, and there's going to be 3,000 results. And you would write some sort of loop that would say for, and we can get into, you know, you would have like an integer, say products, and then you would set products equal to some sort of database call. Let's just say there were 10 products. Okay, so better example would be number of products. Num products. Okay, so the database would say, hey, there's 10 products. So we just get a count. We would have this loop that would start off at 0. Okay, so we're declaring this variable at 0 while num products, we're basically going to loop through the number of products and increment I. Point is, we're going to break this down. Print each product to the page. Okay, so we can write this little for loop that's going to look at each product individually and print it in the page in some sort of table format, you know, that looks good. So this is just a simple example of a for loop, of a loop. Now, if you change this to 1,000 products, you don't have to change what's going on inside this loop. Just print one product at a time to the page. Print each individual. So you realize inside of this loop, you're printing one product at a time. Okay? And it gets really powerful. Okay, 10 products. Okay, 1,000 products. Look, just a couple more products. You don't have to change any of this for logic. This for loop can handle 5 products or 10,000 products. Okay, so that's the power of the for loop, is that it doesn't really matter how many products you have. Okay, you write a little bit of code and it does a lot. Okay, and that's a really simple, real world example of using a for loop. Now, the first, there's many kinds of loops that we're going to discuss, and these are the 3 that we start with. There are other loops, okay, in C#, and we will study more loops, but these are the basic 3. Okay, so we're going to start with a while. And then we'll go to a do while, and then we'll go to a for. Okay, and regardless of which loop you're looking at, each loop has the same parts. And so instead of looking at like the while loop and then I'm gonna study the parts of a loop, right? We're all humans. We have the same parts, so let's study the parts, and then you understand how it comes together. Okay, so the first part of a loop, regardless of a while, a do while, or a for, the first part is what's called the control variable. And so you need some sort of variable that controls the loop. Kind of like the boss, right? The boss. The second part, a test. You're going to test the control variable. We're going to test the control variable. And what kind of test is it? Well, it's actually a Boolean test. What does that mean? True or false. So we're going to say, okay, we got this control variable. Let's test that control variable in a way that says true or false. So just like our if statements have a Boolean expression that evaluates to true or false, there's a Boolean expression here that's going to evaluate to true or false, testing our control variable. And then the third part is the modification of the control variable. We need to change the control variable so that ultimately this test is going to not always return the same answer. Okay, so there's three parts of these three loops. They all have the same parts. The first is what you can call a control variable. It's going to be used inside of this loop to control how many loops there are. Again, is it going to loop 2 times or is it going to loop 1,000 times? Like how many times are we going to repetitively run this code? And then we need to modify that control variable so that it doesn't loop infinitely, right? What's called an infinite loop. If you don't modify the control variable, you have a problem in that you just got a loop that never ends. Anybody remember the Lamb Chops show growing up, the song that doesn't end? Thank you. Look it up sometime. But the song that doesn't end, the loop that doesn't end, that's what comes to mind. Okay. So let's make a control variable. Let's declare and initialize a control variable. Okay, so we know variables. They have data types. A lot of times our control variables, they're declared as I representing the number of iterations. An iteration is like one iteration throughout a loop. If you execute a loop 1 time, it iterates once. If you execute a loop 1,000 times, it iterates 1,000 times. So that's just what an iteration is, a single iteration of a loop. Okay, so we have a control variable, I. We're initializing it to 0. So while I is less than 10, let's test our control variable. Inside of the curly braces, this is our block of code that will execute repetitively. Slow me down if I'm going too fast. 3 parts of a loop. Part 1, declare and initialize your control variable. Test the control variable. Is 0 less than 10 true or false? It's true. If it's true, you go into the loop body. If it's false, you do not go into the loop body. I'll say thanks for using my program. Inside of my loop, we do something. This is the code to execute repetitively. In this simple example, I'll do console.write line hello class. And finally, part 3, modify the control variable, I++. I goes from 0 to 1. So we start off I at 0. Is 0 less than 10? That's true. It prints out hello class. I goes to 1. It tests again. Is 1 less than 10? Yes, it is. It writes out hello class. I goes to 2. Is 2 less than 10? Yes, it is. Prints out hello class. I goes to 3. You can follow along. It goes up to 9. Is 9 less than 10? Yes, it is. Prints out hello class. I goes to 10. Is 10 less than 10? No, it's not. This becomes false. As soon as this becomes false, we continue with the execution of our program. So if we're counting how many iterations, it's iterating from 0 through 9, which is 10 iterations. Vinny?
Is there ever a situation where you need to modify your control variable by like more than one at a time?
Sure, you could do I plus equals 2. You just cut your number of iterations in half, right? Instead of but let's just keep it. We'll just do this. Let's demonstrate this, and this is now part 2. And if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it prints out hello class 10 times. The loop iterates 10 times. The control variable goes from 0 through 9. Those are all true. As soon as that control variable hits 10, 10 is not less than 10, so it breaks out. Now what if I change my test? Less than or equal to 10. Of course, then it prints out an 11th time. You can count 11 times. It's pretty often to use your control variable in your output. Let me demonstrate. Like if I just put I'll put number. Like I'm just gonna use oops, that's 0. I'm just gonna use I as a placeholder. Okay, and this number sign just it'll say number 1, number 2's number. Let's just use I as a placeholder. Now you can see, oops. Didn't mean to close that. You can see that you can count the 11 iterations, 0 through 10 being 11 times. Like if you wanted to start the count at 1, so what I typically do at this point is I start getting you to play with the different parts. Okay? So I'm going to leave my code on here. I want you to just use a while loop. I'm going to pause the recording. Here's the challenge. Use a while loop to print the numbers 15 through 20. 15, 16, 17, 18, 19, 20. I want you to use a while loop to print the numbers 15, including 15, and including 20. 15, 16, 17, 18, 19, 20. Okay, so here's a while loop that prints 1 through 10. So I want you to use a while loop to print 1 through 20. That's 15 through 20. 15 through 20. I'm going to pause the recording. So an exercise like this helps you understand the pieces. And if you understand the pieces, these pieces control the number of iterations. And so the first piece is your control variable. Like if you look at here, I start my control at 1 and it prints out hello class 1 the first time through the loop. And so I don't want to start it at 1, I wanted to start it at 15. So you could change the control variable to 15, right? Is 15 ever less than 10? No. So if I were to run it in this state, it says thanks for using my program because 15 is never less than 10. That's a key point about a while loop. A while loop is called a pre-test loop. What pre-test means is it tests the condition before the body of the loop. So a pre-test loop will iterate 0 or more times. There's no guarantee that the body of the loop runs. because the condition could just initially be false. Well, so what does that mean? That means that the problem that you're trying to solve, if there's a case that there are 0 results in your Amazon search, then you might consider using a pretest loop, because you need to account, okay. So we change this number to what? What do we change this number to? 20. We start I at 15 while I is less than 20. This will say hello class 15, 16, 17, 18, 19, 20. And so the reason, it's one thing to understand the pieces, but it's also realizing by modifying these different pieces, it controls the output of our program. If I change this to 200, what's it going to do? It scrolls through and it prints out all that many times. In fact, the command prompt window is not even long enough to go back to the beginning. Like a setting in command prompt to only scroll so many lines. Right? At some point, this probably breaks. You could do something silly like that, and it's like, this is an integer, and that's too big for an integer. So if you had a real case, there are other data types that you could kind of do something silly like that. But point is, we could do I less than 2,000, and if you watch it, you can literally watch the thing scroll if you're fast enough. I'm not fast enough. So each time it takes a little bit of work, it's doing a little bit of work, your processor's working, the RAM's working, there's a lot going on. Again, important feature of a while loop is a pretest loop. It's also called count controlled. Actually, for loops are really what they call count controlled loops. We'll get into those. A do while is a little bit different. Let's change this up. It has the same parts. A do while just looks like this. Instead of, actually I'll just comment this out. I'll bring this back. A do while has the same 3 parts. Int I equal to 0. Do something while something is true, while I is less than 10. Again, it's pretty common to use your control variable in your while loop to kind of, in this case we're just printing out numbers, but you can do other things with I, your control variable. Especially as we get into arrays, we use it quite a bit. So it doesn't like something here. Let me look at my error. It says input string was in a correct format, format error, somewhere on here. Scroll over. Line 27, doesn't like line 27. Oh, I is 0. I keep doing my placeholder is 0. I is my variable. I talked about a problem called an infinite loop. And I don't know if you could tell, but this is not changing I. I is always 0. What's happening is we're saying, okay, hello class 0. Is 0 less than 10? Yes, it is. Print out hello class 0. Is 0 less than 10? Yes, it is. The song that doesn't end, right? What I forget? I forgot to modify my control variable. I forgot the I++. I created one of those infinite loops. Now it iterates 0 through 9. a while loop and a do while loop basically can do a lot of the same things. What's the difference? Well, a do while is a post-test loop. It will iterate at least once. It will iterate at least once. So let's demonstrate that. If I set I to 100, is 100 less than 10? No, it's not. But it will still execute the body one time. So the way this works is it will execute the body of the loop, and then it will test. Is 100 less than 10? No, it's not. So it will say, thanks for using my program. So even though this condition will never be true, it still runs the body of the loop one time. And as a demonstration of that, it says hello class 100. Even though that condition is never true, it's a do while. So you're guaranteed that that body of the loop executes one time. And to Vinny's point, what if you want to increment by 2? So let's start off I at 0. What if I do I plus equals 2? Notice I start, my controls going from 0 to 2 to 4 to 6 to 8. Printing out even numbers essentially, less than 10. Starting at 0, if you want to start it at 1, you wouldn't have to print out, maybe we start at 2. And now we're not including 0, 2, 4, 6, 8. So these are even numbers between 1 and 10. Let's go ahead and use a do while loop for practice. Go ahead and do a do while loop to print out odd numbers between 1 and 10. So I want 1, 3, 5, 7, and 9. Vinny, you had a question.
Yeah, I guess just like what I was asking was like, what's a real world example like you would use that where you increment more than 1? You had the basketball example.
Yeah. Most loops, to be honest with you, most of the times you're just incrementing by 1, to be honest with you. Let me think about that. There's nothing that jumps to my head right away.
What, that you'd be incrementing?
Incrementing more than 1. It's a good question. You know how many times in my life I've lectured on loops, and I don't know that I've ever had that question asked. If I have, I'm forgetting. Let me think. Just because you can do it doesn't mean you should do it. And I'm just thinking most of the times you're just trying to say, okay, repeat this code 100 times. So start it at 1, go up by 1. There are like what I would consider to be programming exercises where to learn a loop, I could give you some challenges. But as far as the real world application, I say most of the time you just go up by 1. That's really all it is. Doesn't need to be any more complex than that. If I could think of another answer, I'll let you know. So again, the challenge here, let's print odd numbers from 1 through 10. And in other words, 1, 3, 9, 1, 3, 5, 7, 9. Okay, using a do while, I want you to print those numbers. I'll go ahead and pause the recording. Okay, so again, just tinkering with this. We want to print 1 through 9, so let's start at 1. Let's go up by 2. So it'll go 1, 3, 5, 7, 9. There you go. It's really 1, 3, 5, 7, 9. again, for programming sense, you can't actually have multiple control variables. It's not super common. You can say while I is less than 10 and j is less than 2. How many times would this iterate?
Twice.
Just twice. Because both of these have to be true for the overall to be true. So I doesn't even matter because really it's j that's controlling it. Because j is going to be 0, j is going to go to 1. And 1's less than 2. Print out, and it'll run again. J will go to 2. Is 2 less than 2? No, so it iterates at 0 and it iterates j at 1. So it iterates twice. To demonstrate that, we're not even, we just print it twice. Yeah.
So I've always had trouble with loops, especially last semester, but like, so a while loop, they test it, and if it's not true, then it doesn't do it, or it does do it if it's true. But a do while, it always does that first.
At least once.
That first block, at least once. So
That is absolutely correct.
everything else is basically the same though.
Yeah. Yeah, the different pieces are the same. But it's again, so the main difference, pre-test versus the post-test. Pre-test is no guarantee it'll iterate.
Mhm.
Post-test, at least it'll iterate one time.
Okay, gotcha.
Yes?
My one's not like showing up, like it just starts with 3.
All right. Good question. Let's bring it back. Okay, let's get J out of the equation because let's just, again, you don't see that super often, but it is possible. You have multiple control variables. Does it matter the order of operations? What if I do this? Does that actually change my output? So notice I'm incrementing I before I'm printing it out. So this will take I, it'll go to 3 right away and then print out 3 instead of starting it off with 1. So this actually goes 3, 5, all the way through 11 because again, it increments it first and then it prints out the result of that. Right? So order of operations in your loop do cause a difference in your output there. All right. So we're going through these loops quickly. If you feel like there's a lot being thrown at you, that is true. Okay? We have 2 days of lab to really master this. Again, how you master this, you need to read, you need to pay attention during lecture, and the most important piece, practice, practice, practice. Okay? The last loop is a for loop. What's beautiful about a for loop, the beauty of a for loop, is that all 3 pieces can be observed in one place. So if you think of that, what do I mean? For int I equal to 0, I less than 10, I plus plus. We got one line of code right here. 3 things happen right here separated by semicolons. What's the first thing? We are initializing our control variable, giving it an initial value. Now in this for loop, I'm both declaring and initializing, but really you just, in theory, you typically see at least the initialization here. Okay? After that, we test. Then we iterate body of the for loop. Then we increment. So one thing, again, I'm going quick here. First step of a for loop, init the control variable. That's putting the equal sign on a variable. Step 1, initialize a control variable. Step 2, test the control variable. That comes right here. Step 3, in a for loop is actually to run the body of the loop, if true. If true, run the body of the loop. Step 4, modify the control variable. So I'm going to highlight this, and I want you guys to watch my highlights. Okay? Everyone watch. Step 1, initialize the control variable. Step 2, test the control variable. Step 3, body of the loop. Step 4, update the control variable. Step 5, test. Step 5 goes back to the test. So here I would say test, and if true, so this is kind of like back to step 3. Test, and if true, run the body of the loop. Modify the control variable. Test and run the body of the loop. Modify the control variable. Test and run the body of the loop. Vinny.
So is a for loop a pre-test loop?
It is a pre-test loop. A for loop is a pre-test loop, just like a while loop, where all 3 parts are in one one line, and the benefit of that is that it makes your code easy to read. In theory, okay, I'm going to go back to my while loop. In theory, I could have a control variable on line 23. Then on line 3000 of my code, I got a while that says I is less than 10. Okay, pretend this is line 3000. So way up here, I've got this random variable hanging out. And then way over here, I've got this while loop. And let's just pretend this while loop is a huge while loop. I got all these lines of code. We could say, if this condition, if true, I++, else I minus minus, so modifying the control variable, testing the control variable, initializing the control variables, they're just scattered all throughout your code. So when you're debugging, right, let's just pretend, someone writes this while loop and it's not working properly. I'm trying to fix it. I'm having to dig through thousands of lines of code to try and find the different pieces to understand how many times this loop is supposed to run. Right? And the benefit of a for loop is that it's all right in one place. Okay, so I'm going to get rid of this while loop example, kind of highlighting the problems with a while loop. Okay, and just bringing it back into the for loop. And if I just console.writeLine hello class number 0, comma I. This is going to iterate 0 through 9 times, just like a while loop. And I broke my curly somewhere. I'm sure I have too many or not enough. There we go. So this is using my for loop to do the same thing we were doing with our while loop. And what if I want to increment it by 2? As Vinny said, I'd say I plus equals 2. Actually, the book even will go through this. Believe it or not, it's very strange, but believe it or not, you actually want to do plus I versus I plus plus. And there's actually some reasons there why this will actually function like milliseconds faster. Again, you can kind of read into the book why that might be. Like, ultimately, they're both incrementing I by 1, but it's just a built-in that's a slightly faster. Yeah.
I was going to say, is that really that important to where?
Okay, is it that important to save milliseconds? In our small programs, no. Okay. In the real world, where you might have a lot of these loops, and these loops might iterate a lot of times, those very small things can add up, and they do add up. So if you can learn to be more efficient and do the small things, that over time those things can add up and make a difference in performance. But in these small like school examples, you're not going to notice it. Yep.
I know last semester in JavaScript we also used like for loops. Are there for loops?
We'll get there. We'll get there. Yeah, there's for each loops. For each we'll use a lot in this class. Yeah, there are other loops. I just wanted to cover the basic 3. Okay? So went through that lecture quick, but it did cover the 3 different types of for loops. And I'll tell you what, tomorrow we'll review a little bit before we get into lab. But literally that's, oh, there's one more thing. Continues. Sorry. Continue versus break. These are 2 keywords. Continue will stop the current loop and resume the next iteration. So you might have a loop. Okay, here I'll do a for loop. I'll do a simple for loop. By the way, for tab gives you a snippet. Check this out. For keyword for tab gives you a snippet of a for loop. Okay, council.writeLine I. Okay, I. So I just want to show you this for loop. It's going to go 0 through 9, which is right here, 0 through 9. Let me get rid of my other example. Okay, very simple for loop, printing out 0 through 9. I'll say if I double equals 5, continue. Okay, and again, you could put curly braces around this just to if you hit the keyword continue, it stops that iteration of the loop and then will increment I and then run its test. So what's going to happen here is if I hit a continue, notice it goes 0, 1, 2, 3, 4. It does not print out 5. Because when I was 5, it hit a keyword continue and then resumed the rest of the loop. Okay, so there are ways to modify loops using this keyword called continue. The other keyword is break. Break does not resume after that. It just stops. So break terminates the loop completely, whereas continue just terminates that iteration. Okay, and if you look at the book, they say that a little bit differently, but they say, you know, like a break will put you at the end of the while loop, right? So, and then this will put you at the top of the for loop, right? So they say it like, where does it return control to, right? They say it a little bit differently in the book, but you got to just, now, rule of thumb that I learned, and this is still true, my understanding to the most part, these exist for you to use, but you want to use them sparingly. They're not considered good practice. The reason they're not considered good practice is because they modify the default behaviors of a loop. And so when you're trying to like troubleshoot and fix problems, and you got these breaks and continues scattered through all out, it can really make it hard to troubleshoot. Okay, so these keywords do exist. You can use them in this class, but if you can figure out a way to not use them, it would be better. Okay, so that's a kind of a rule of thumb. All right, we had a busy Monday. I'm going to stop the recording here.